So welcome everybody to our last workshop of this quarter. Today we're going to be talking about how you do surface mount soldering. So this is our last workshop of the quarter, as I mentioned, so we haven't actually picked all of the workshops for next quarter yet. So if you guys have anything you want to see, feel free to reach out to Jackie or I with ideas, and we'll be happy to take a look at those. But let's get started. So today we're going to be covering four main things. The first of those is just kind of a general overview behind what SMD soldering exactly is and how it compares and contrasts with through-hole soldering. And as a fair warning, I can guarantee you that a couple times today, I will say surface mount soldering when I mean through-hole and vice versa. So hopefully it's easy enough to distinguish. So number two, we're going to be talking about the pros and cons of each through-hole versus SMD and situations in which you'll use one or the other. Three, we're going to talk about what you're probably most interested in, which is how you actually do it. There are several different methods for through-hole soldering, and we're going to be talking about each one. And then what I think is the most exciting one is number four. Jackie has designed a wonderful little PCB game console for you guys all to assemble. So that should be really cool, and we're going to spend some time at the end getting that done and answering your questions about it. I think the lecture portion of today might be slightly shorter than what we're often used to. But that's so we can leave some time for the project at the end. So first of all, what exactly is SMD soldering? If you know what it stands for, then you can put it in the chat. I think it'll probably be pretty easy to guess what the first two letters are, but does anyone know what the last one stands for? Nobody? All right, we have an answer. Surface mount device, that's correct, Justin. So if you look it up, if you Google SMD, you'll also come across something called surface mount diode, which I guess is a type of surface mount device. And if you Google it, you'll also come across a rather impolite text slang phrase. So I wouldn't recommend it. Anyway, let's continue on. So let's take a look at some surface mount devices. As you might expect, these are individual electronic components that are mounted directly onto the surface of your PCB. And this is as opposed to the through-hole soldering we've done before, where it's mounted actually through the board. And so there are some side effects of this. One of these is which it just is on one layer of the board, as you can see above. So whereas through-hole components will connect both the top and bottom layers electrically, the surface mount components will not do that. They will only be on one side of the board. And because of this, because they don't have to go through, there doesn't have to be that stability, we can make components a lot smaller. And that's one of the benefits actually of our surface mount components. And you can see some of the sizes of these on the bottom left. And they have their sizes listed right here. 0603 is a size. I think that's the smallest that you can really safely surface mount solder by hand. And then it just goes up from there, although there are smaller ones that you can use a heat gun on and other kinds of things like that. So let's talk a little bit about the differences between through-hole and surface mount and some of the benefits of each. So through-hole just provides a stronger mechanical and physical bonding, and this is simply because it has the added security of actually having its metal legs through the board, as well as the connection of the solder onto it. And this means that if, for instance, you got it caught on something, it'd be less likely to break off, whereas a surface mount component might do that. Now, a downside to through-hole soldering is that it requires drilling holes on your PCBs. For one thing, this takes up extra space. And for another thing, as I mentioned before, it connects both the top and bottom layers and any layers you have in between. And so this will limit your routing area that you can have. And I know if any of you have experience with routing large boards of through-hole components, then you can run into some difficulties finding ways to do that. Now, through-hole components, as you've probably seen before, are actually really good for prototyping though. For one thing, you can stick them in breadboards to make electrical prototypes and connections that way. And it's also good because it's a lot easier oftentimes to exchange components on a through-hole board without damaging the components. Whereas with the surface mount component, you'll probably break the part if you try to do that. So as for surface mount components, as I mentioned before, they tend to be a lot smaller than your through-hole components. And there's a lot of benefits of this, one of which is that you can fit a lot more components on the same square footage or square inchage on your PCB. And this will make a much smaller, denser PCB. And even on top of that, you can mount PCBs in the same region, but just on opposite sides of the board, which is something that you couldn't do with through-hole soldering. And for these reasons, it's a lot more popular to use surface mount soldering in industry. If you've ever taken apart any just standard commonplace electronics, like for instance, a thermostat, you'll see a lot of surface mount components on the boards that use in those. In fact, one of the few areas that they actually still use through-hole soldering in these days is high-end boutique guitar amplifiers. But that's just because those manufacturers are very old-fashioned that way. One last thing about surface mount components is that it's just a little bit more difficult to deal with than your through-hole components. And that's purely because of the size. It's a lot easier to lose components. It's sometimes more difficult to line them up correctly on pads. So that's just something to bear in mind when you're thinking about what type of component to use. So here's another list of reasons to use one versus the other. Surface mount components are often used in high power situations, and this is just because of their physical nature. They're small, so they often can't sink the amount of power that a larger physically through-hole component could. And this is also sort of connected to the next thing, which is surface mount components may sometimes fail in high stress situations. They're due to the environment or stresses of electrical surges, stuff like that, whereas through-hole components are pretty robust. Now, surface mount components are notably less expensive at scale, also because of their size. It just uses less materials. So it gets really impressive if you've ever gone on DigiKey or Mouser and typed in how much it is for, say, 500 of a really, really small 0603 resistor. It gets down to mere cents per unit, which is quite impressive. Whereas through-hole components don't tend to get down quite that inexpensive. We talked a little bit before about the fact that through-hole components are mostly used in prototyping, or proof of concept is another way we can phrase that, whereas surface mount components are more often used in production. Next, it's good to note that we can put surface mount components on both sides of the board. I think I already mentioned that, and that they just take up less space. So let's take a move on. So I mentioned a little bit before as well, the concept of package sizes. And that can actually be a little bit confusing because, as you see, we have two different ways to do that. We have a metric code and an imperial code. And this wouldn't be particularly confusing, except for the fact that they use the same combinations of numbers, which seems pretty stupid. Seems like they could have figured out a different way to do that. But you can run across issues if you think you're using an imperial code 0603 size piece. So you design your PCB with that footprint, and then you accidentally order a metric code 0603 because those pieces won't fit together. That'll mess with your design. So you have to be very careful to note which one of these you're using. And as you can see, metric code, of course, is just dealing with millimeters, and imperial code is dealing with inches. So I think that the ones I tend to use at least are imperial code. I don't know what exactly the standards are, but I would assume that would vary by country. So one thing you actually might like more about surface mount components as opposed to our through-hole components is reading resistor code, because I know most of you probably haven't taken the time to memorize the resistor color code. You're probably looking that up whenever you have to determine what value a resistor has. That becomes a lot easier actually on surface mount components because they just have the digits printed out on the back. And so you can see over here, it follows the same sort of scheme that our color bands do. So the first digit is the first digit, second is the second, and then the third is the number of zeros following that. So you can see right here, 473 indicates a 47K ohm resistor. I think there's a typo at the bottom of this graphic because the 4-digit resistor code is a similar thing, but the first 3 digits are the first 3 digits, and the last one is the number of zeros following that. So both of these should represent a 47K ohm resistor. All right, so next I think we have an Amazon gift card giveaway, which is always exciting. So I'm going to delete this white square, and afterwards you guys put your answers in the chat and I will judge which ones work. I think this is a slightly more open-ended question than the ones we're usually used to, but get your keyboards ready. All right, there we go. So type your answers to the question in the chat, and the first and best answer will get. All right, looks like we've got a lot of good answers in here, but the first one Corwin, your answer much more compact. That is true, and you are very fast. So Corwin, congratulations. You'll be getting our Amazon gift card this time. Nice job. Oh, wait a minute, you're right. It has a advantage of Throughhole versus SMD, so you are wrong. Okay, never mind. Let me take a look back through these answers. Okay, we have much more impact, more rigid. Derek, that's technically true. I'm not sure I like the answer rigid though, because technically the parts are a lot more bendy because they have leads for the most part, whereas your surface mount components don't actually move at all. So I think that Cameron's answer, it's more robust, is a bit more true. So yes, we're actually going to give it to Cameron this time. I think we have your email, but would you put that in a private message to Jackie in the chat? All right, good job, everybody. There's a lot of good answers here. And let's move on real quick. Let's get into the actual details of what we're doing today. And that is, of course, soldering methods. So the first of these methods is going to be with an iron, and that's what you guys are going to be using, since I think you all should have one by now, either from last quarter or from ordering one to go along with your kits this time. And so that's the most rudimentary way to do it, and it's the way that people who can't afford things like the other two methods will use. The second one is a heat gun. And this is where you basically apply a concentrated beam or wave of heat through your PCB to heat up the solder or the flux at the appropriate way so that it melts and gets your pieces onto the boards. This is a less direct method. It's just a general heating of your board. And the same concept sort of applies to a reflow oven, which is just like a large heat gun that you stick your PCB in with all the components attached. And then when you pull it out, they've all been soldered onto the board. And I believe the IEEE lab has actually just gotten a new reflow oven. So when we get back on campus, you guys will be able to check that out. But for now, let's stick with the iron method. Oops, 1 sec. All right, so here are some visual representations of what you want to do when surface mount soldering with your iron. So unlike in through-hole soldering, which you're used to, you're going to first tin one of the metal pads. And this means just put a little drop of solder onto the pad, as you can see in the bottom left right here. So you're not going to even deal with your component for the first part. Just make one of your pads have a little bit of hard solder on it. Your second step is going to be to take your tweezers, pick up your tiny component, and then you're going to put it on the board. And you're going to line it up so that the pads are all in the correct places with one of them over that little glob of solder that you added. And once it's over the glob of solder, what you're going to do is you're going to apply the tip of your soldering iron to that leg, and you're going to melt it so that it sticks on correctly. And you have to make sure this entire time that all of the legs are exactly lined up, or you're going to run into trouble. So once you've done that, you can proceed around the other legs of the piece and solder each one of them until all of your pieces are on the board correctly. So let me just mention again that you really do want to be careful to make sure your pieces are aligned correctly here. It's very easy to solder on one leg, but have it slightly crooked so that the others won't work correctly. And that's very difficult to deal with. So make sure that your components are positioned correctly before you start soldering more than one leg. So let's take a look at what the joints look like. If you do a correct joint, your piece should be pretty flat on the board. There should be just a little dome of solder over each side of it, as you can see in figure 6B over on the right over here. So you want to make sure that that first leg is flat before you try soldering the second leg. You might notice sometimes that pieces are sort of angled on the board, and this is an easy mistake to make. Sometimes it'll work, but sometimes it will not. And so you want to be careful to make sure it's flat on the board. It looks nicer, and it's just a way of ensuring that your connections are good.
And here's some tips for SMD soldering. So when you want to first solder the joints, you want to solder on opposite sides. So as you can see on like the orange arrows, if you have a multi-pin IC, you want to first solder one side of the pin and then on the opposite side so that it's more secure when you're soldering the other pins as well. And another tip is to use Flux. I know a lot of probably most people don't have this with them right now, but basically Flux prevents the oxidation of melted solder, and you don't want your solder to be oxidized because it turns really dull and kind of like grimy, like in the bottom picture on the left. And what that does is prevents you from like creating really good solder joints. And what you would want is just really shiny solder at all times. A common mistake that a lot of people make when they're soldering these ICs where the pins are really close to each other is accidentally bridging the two pins together with solder. And this is something you don't want to do because you will essentially short the pins, and it's not, your PCB is not going to work as the way that you intend it to. So a thing to fix this is to use solder wick. Sometimes if you just like melt your solder iron as well, and you just heat like that area of solder, the solder will stick onto the solder. The excess solder will stick onto your iron, so that you can take off the excess solder that way. Alternatively, you can use flux before you actually solder, so that it prevents this bridging mistake. Some other ways that people do like SMD soldering, not just with like the iron, is using a heat gun slash a reflow oven. And basically the process to do this is applying a solder paste rather than using the actual solder metal. And you would apply this paste using like a syringe, or sometimes when you order PCBs, they send you a stencil where you can just put the solder paste on that. And then after you put the paste, you just put the component onto um, the paste, and it'll basically stick like kind of like glue. But to actually secure it, you need to apply heat using the heat gun, or you would throw your PCB in the reflow oven and put it in for like about a couple minutes and then have it solidify. And so now we are going to play Kahoot before we get into the actual soldering project. So please go on to, or I'm gonna share my screen right now. Okay, so that everyone can join. And so the game pin is 7775955. Also, if you have any questions, like feel free to unmute yourself or like drop it in the chat. I'm gonna just wait a couple minutes so that everyone can join.
Just a quick question, and I don't know if we covered it, but are the slides available somewhere on the internet?
Oh yes,
I can copy
Travis
those for
sent
you.
it in the beginning, but he's gonna send it again right now.
There's the slides, and I've got a check-in link for you too, if you would.
Yes, make sure you guys check in so you get your deposit back.
And as always, this Kahoot will be for an Amazon gift card, so give it your best.
Who's the Berlin Ninja?
I think we know who that is.
I think there's probably a couple more people. I'm gonna wait for it to go to 20, I believe. Is there anyone having trouble logging in? Okay. I guess not, so we'll just start right now. Okay, first question, what does SMD stand for? Surface mounted device, saturated mounted diode, soldered mounted device, Stacy's mom and dad. I too pick green. Yes, surface mounted device. So Derek's at the top, followed by Berlin Ninja and Cayenne. All right, second question, what is one advantage of SMD soldering? Component is soldered to only one side / layer of the PCB. Component is soldered to all the layers of the PCB. It's much larger than through-hole components, or it has a stronger mechanical bond. And so the component is soldered only to one side, essentially the surface of the PCB. Still got Derek on top, followed by Juan. Right, question 3, which type of soldering would you use for prototyping? Through-hole or SMD? Yes, through-hole, because it's pretty much inexpensive and there's a lot that you can find. All right, true or false? A capacitor and resistor can have the same footprint. Now remember what we talked about, different footprints and sizes. So it is true. Derek still up top, followed by Krisha and Justin. What is the first step to SMD soldering? Solder one side of the component on tinned metal pad, tin one metal pad, or place component with tweezers. All right, so we always want to tin one metal pad first before we do anything or place our component. All right, second to last question, what does flux do? Makes the solder duller. It's used in place of solder, prevents oxidization of melting solder, and provides cleaner binds, or it doesn't do anything and it's just for aesthetics. Yes, so it prevents the oxidization and makes it nice and shiny. All right, we got one last question left. True or false? You should leave your battery plugged in while soldering. Should be false. You do not want to leave your battery plugged in while soldering because your solder iron will get really hot and your battery gets to a point where it's just out of control, very hot. It's not a good sight you want to see. So we got third place, Krisha, second place, Justin, and first place, Derek. Okay, so Derek, please DM me your email so I can send you the Amazon gift card. And then now I'm going to share my screen again. Does anyone have any questions? Okay, thank you, Derek. All right, so now it's time for us to start soldering. Before we get into it, please make sure you have these items in your bag, and I'll just go over what you should have. Make sure you're also in a very clean and open space. before you solder, because some of these components are extremely small, and if you lose them, they just end up going into like the void or some other universe because you'll never find them again. So first, I'll start from like the biggest parts first. So make sure you have the PCB in there. If you don't, then I don't think you would be able to solder. But if you have anything missing, like feel free to send in the chat. Okay, so you have your PCB right here. Then you will need your 3.7 volt battery. You can open up the box and check for it inside. Then you should have a GST connector, which your battery will connect to so that you can put it onto your PCB. Then you should have a 5 volt step-up voltage converter, which basically converts this 3.7 volt battery to 5 volts that you can feed to your MCU. Next, you should have an OLED display right here in like a little plastic container. And then you should have one set of tweezers, which you will use to essentially grab your components since they're really tiny, and then place them on your board. You should have a joystick, kind of like PSP like joystick. You should have 2 buttons that look like this. Also, let me know if I'm going like too fast. Sorry. And then you should have these 3 different female headers. So you need a 6-pin female header, a 4-pin female header, and a 3-pin female header. And then you also need a 3-pin male header, which you will use to solder onto your 5 volt step-up voltage converter. Since there's 3 holes where this pin will basically go through. Then you will need 4 10K resistors, and it's pretty hard to see them right now, but they're actually, I think I can. They're like black, and it should say 103 to denote 10K resistor value. And then they should be smaller than your 100 ohm resistors, which should say 100 to denote, oh, sorry. Yeah, 100 to denote this 100 ohm resistor value. Then after that, you should have your MCU. This is the AT Tiny 84. It's essentially kind of like the same MCU that you would use for your Arduino Nano or your Arduino Uno, but it's just in this IC form and has less pins. Then you need your slide switch to essentially turn on and off your game console, and it should have 6 legs on here. And then finally, we have our buzzer and our capacitors. So this is the buzzer right here. It's pretty bulky. And then this is a little bit tricky, so make sure you pay attention. You have these 10 ohm capacitors. You only need to use 1, but I just included 2 in case you lost one. And the clear packaging is the 10 μF one, and then the one with the white packaging is 0.1 μF. And the capacitors should essentially not have any writing on them. Okay, once you guys have checked to make sure you have all the parts, please message in the chat. All right, thank you, Margot, Brian, Dominic. Okay. Is there anyone who's still checking or hasn't gotten them?
Quick question, who packaged this?
I packaged them individually. Did something happen to it?
Nothing, thank you.
No problem.
Sounds like a lot of work just to package all these things.
Yeah, I was like, I had a count to make sure so I didn't lose any of the little components. Oh, I forgot to mention there's these LEDs right here. I'll show you in the video, or I'm gonna show my other camera the polarity of the LED. So just hold tight on that. Okay. I'm gonna attempt to turn on my camera here. I'm gonna turn off. Sorry, I'm gonna see. I'm gonna stop sharing. And then I will spotlight my other camera. Okay, can everyone see the PCB right here?
That's good.
Okay, sorry. Okay, so this is how your final product should basically look like. So as you can see, you have your joystick right here. You have your buzzer, your six pin female header. Then you have a 4-pin female header so that you can essentially just insert your OLED display right here. And that you can basically reuse it for like a different project. You have your LEDs right here. And then you have your 100 ohm resistors here, your 2 buttons here, your slide switch here, and then you're gonna solder your 3-pin male header right here so that you can insert your 5-volt boost converter, and then you're going to solder your JST connector right here. Actually, oh, good. This one is like a different version, but essentially for the back, the JST, you're going to solder it facing downwards so that your battery can essentially go like this, and red for like your battery will denote like your positive lead, and black will denote ground. So you see the negative lead right there. So you need to make sure your battery can fit into the JST in this position. And then you're going to put your MCU right here. Make sure you solder it with the notch on the top. Otherwise, it's going to have a flip polarity if you solder it with a notch on the bottom. Then you have your 2 capacitors here, 10 μF and 0.1 μF. And then that's pretty much it. I'll show you how it should look like in the end. I'll just, okay. Let me share my audio. Okay, so So basically to turn it on, you just flip it right here, and then it should play like a little song from the buzzer. And the pre-uploaded game is tic-tac-toe. So you can just like use your joystick to move around, and then you press A to place your button, place your piece, and then you keep going until like someone wins. And then if you want to restart your game, you just press B, and then it's recess. Okay, so I have instructions on which components you should solder first on the slide. So let me reshare my screen. Okay, so once again, make sure you don't solder it with your battery plugged in. And the instructions for SMD soldering: solder one pad first, and then put your component on that same pad, and then solder that one end of the component so that it's in place before you solder the other side. And then all the components you want to place on top of the side with the white label. So as you can see, like this is labeled LED. You want to place the LED on this side rather than the other side. Same thing for the through-hole components. You have your joystick labels like right here. And that solder mask, that white solder mask. And so the very first thing you want to do is solder your LEDs, 100K ohm resistor, and your 100 ohm resistor. So I'm going to do a quick example on my phone so that you guys can get used to soldering yourself. Okay. So I hope everyone can see that right here. And the very first, I'm going to solder the LED first. So the polarity, oh, I'm going to take one out of the component actually.
Sorry, is it
Really
possible
small.
for you to share your iPhone screen instead? I think I'm still stuck on your slide screen.
Oh, okay, sorry. Can you see the spotlight now?
Yeah, I can see it now. Thank you.
Okay, sorry about that. All right, so for the LEDs, you can see right here that there's a vertical line and like a horizontal line. The vertical line should match up with the vertical line of this like triangle of the LED. And then this denotes that the left side is the positive side and the right side is the negative or like ground side. So if you just have it like this and you, oops, and then you flip it, it should match up with the line. Let me redo that. Okay, so if I flip it over, the vertical line should match up with the left side of this triangle. And so the first step, you want to solder one side of the LED or one side of the pad. So I'm going to heat it up and then place my solder right here. And then as you can see, the left side, I put solder on there. And then now I get my component that I dropped over here. Make sure the polarity is correct. I don't know if you can see that. Okay, so the left side is the vertical line. I'm going to place that right here. And then what I usually like to do is like heat it up and then slide it onto there. So I heat it, and then since it's like in its like melted state, I'm going to just slide it right there. and then place the component. And now I'm going to solder the other side. Place some solder and then have it like that. So make sure you don't like put a bunch of solder on there. Minimal is always better. And then you would do the rest for the other components.
As a quick aside on top of that, I think the soldering kits that we recommended came with multiple tips, if I recall correctly. So this might be a time, if you're using one of the thicker ones, to move on to one of the thinner ones. That'll just make it a little easier on you.
Yes. And then one thing to note for the switches, let me get it real quick. So for the switch, make sure there's like a little label that says C&K on the bottom of your switch, or like a little engraving, and that should be on the bottom towards this like on area. So C&K, can't really tell. Okay, cat. So the LEDs, let me get another one out. Basically, the vertical line denotes the positive side. So the horizontal line is ground. Does that make sense, Kat?
I think so. So if I'm looking at it like, so that the long side is vertical, you mean that the top of the T is positive?
So imagine you took that T and made a triangle out of it. So that would be going the same direction as the triangles on the
Okay,
board.
cool.
That makes sense.
That makes sense.
I kind of put a little note on there so everyone can see. Is the solder below the LED? Can you expand on that? So I place the solder like on the pad, and then I slide the LED so that's on top of the solder basically, and that's leveled. Does that answer your question? Okay. All right, and then okay, so just stick to soldering the LEDs, the resistor, and the resistors up here as well before you move on to anything else. Oh, there's also 2 pull-up resistors right here for the buttons.
And those are the hard parts. So once you get those out of the way, the rest of it will be a piece of cake.
Mm-hmm.
So I'm going to stop recording right now because for I think the next length of time, we're going to just be answering questions that you guys might have.